Okay, in this video, we're going to be having a look at composite and inverse functions. So I'm going to start off with composite. What does composite mean? Composite means two or more things stuck together. In English, that is what a composite of things mean. A composite of materials are two materials that have been stuck together. So a composite function is two functions or more, but usually two, that have been stuck together. The way that we write it is, for example, something like this. The function f acting on the function g of x. So let's have a look at some examples of how we would go about solving one of these. So let's say, in this case, I'm given f of x as x squared plus 1 and g of x as 2x minus 3. Okay, nice basic functions, nothing too crazy. When I'm looking at my composite function, my f function is acting on my g, meaning if I put an extra set of brackets around that, I can think of it as my g of x is my input, my domain. It is my input of the f function. So I would take my f function, which is x squared plus 1, and I would replace my input, which is x, with g of x, my new input. My f of x, written as usual, my x is my input. Here, it's been replaced with a g of x, so here it is going to be replaced with g of x. So I'm going to take my x, replace it with a g of x, and once I've expanded this, it will get me the overall form of my composite function. So we're going to end up with 4x squared minus 6x plus 9 minus 6x plus 1. My composite function is 4x squared minus 12x plus 10. If we had an extra number in here, so let's say, that's my rubber, found it. So if I replace it with a number, then quite simply, I'm doing it step by step. I'm taking my g of x, which is my new input, and I am changing my g of x to be g of 2. So I'm putting 2 into my g function. So 2 times 2, 4, minus 3 is 1. And then I am putting this into my f of x. So f of g2, or g2 is just 1, is f of 1, which is 1 times 1 plus 1 is 2. And this is how composite function works. And now let's move on to inverse functions. So, an inverse function at its core is, and unfortunately everything is graphical, so I'm going to show it on a graph. An inverse function is taking a function, so I'm just going to draw in, use red, a random line, let's say that's 2x plus 5, and it takes it and it mirrors it in the line y equals x. So let's say we take a mirror along y equals x and we flip it. Now this will be a horrible drawing, but maybe something like that. I think it would probably be a little bit more skewed in reality. Chuck it into Desmos, don't rely on my drawing. But it reverses it in the y equals x graph, which does kind of make sense. Inverting something, we can think of as flipping the input and the output. If we're flipping the input and the output, we're flipping the y and the x, so it should be flipped in the y equals x line. It all kind of goes together. So, that being said, without the graph and without drawing all of that, how do we inverse a function? Well, it's not quite as easy as flipping the x and the y, but it almost is. So let's take, for example, 2x plus 5 equals y. Most simple example. First of all, if this was given equal to f of x, get rid of the f of x, replace it with a y. It will make things a lot easier. If you consider f and x and y the same thing, they're both outputs, just easier to work with a y. Now, what we would do with this equation in order to flip it is we would rearrange it in terms of x. So we have it in terms of y, but I would like it in terms of x. So let's minus a 5 from both sides, divide across by a 2, and I get y minus 5 over 2 is equal to x. Now, all I've done so far is rearrange it. I haven't changed anything about the function. And this is where the idea of flipping the input and the output comes in. Once I have rearranged it for something that equals x, I'm going to take my y's, I'm going to take my x's, and I'm going to flip them. All of my y's will be replaced with x, and all of my x's will be replaced with y's. So my final inverted function will be x minus 5 over 2 equals y. So my inverse function, which we write as f to the minus 1x, is equal to x minus 5 over 2. Now, let's just have a look at one more tricky example. Okay, let's finish off by having a look at this example here. So I've got my function f of x as 2x plus 1 over x minus 2. Remember, first step, just make things a little bit easier for ourselves. Equate it to y, ignore the f of x, we know that they're the same thing. Now, I want to rearrange for x. So y times x minus 2 equals 2x plus 1, cross multiplying my x minus 2 there. Now, how do I get this in terms of x? Well, I'm probably going to want to start by expanding this side here, because I've got an x inside a bracket and an x outside of the bracket, and that makes it a bit tricky. So I get yx minus 2y is 2x plus 1. Now I'm thinking, okay, I probably want to get all my x's onto one side, all of my non-x's onto the other. So let's minus this 2x, yx minus 2x. Let's add this 2y, 1 plus 2y. Factor out my x. I get x, y minus 2 equals 1 plus 2y. And hence, dividing by the y minus 2, my x is equal, this is a bit crooked, apologies, over y minus 2. So that's my system rearranged, but remember this is not my final answer. This function is still identical to the first one. In order to invert it, I need to flip the input and the output, I need to flip the domain and the range, I need to flip the x and the y, those three statements are the same, and it will turn into, my x turns into a y, my y is turned into an x, 1 plus 2x over x minus 2. And that is equal to my inverse function.